Hello and welcome back to another video. In this problem, we're asked to use the definition of continuity and the properties of limits to show that the function is continuous at the given number a. So we have f of x is equal to 3x to the fourth minus 5x plus the third root of x squared plus 4. So what we're going to do is we're going to split this into two different functions and say f of x is equal to g of x plus h of x, where g of x is equal to 3x to the fourth minus 5x, and h of x is equal to the third root of x squared plus 4. G of x is a polynomial. H of x is a root function. And therefore, we can say for both of these, from Theorem 7, we can say that these two functions, polynomials and root functions, are continuous at all values within their domain. Therefore, we can say g of x is a polynomial, so it's continuous everywhere because it has no domain restrictions. So g of x is continuous everywhere. And h of x is a odd root, therefore it is continuous everywhere. Right? If it was an even root, then we'd have some restrictions about not being able to take the square root of a negative number, for instance. But since it's an odd root, we can take the odd root of any number. So g of x and h of x are continuous everywhere. And therefore, by Theorem 4, we can say that since f of x equals g of x plus h of x, f of x is also continuous everywhere. Therefore, at a equals 2, just like for any other value of a, the function is continuous.